Hello everyone, I welcome you all on Photonic Edu. This is the very first video of the series Differentiables or Derivatives. So, here in this first video, I'm going to discuss with you what a derivative means and how does we utilize in physics. So first of all, we need to know what a different derivative or a dy dx generally means. So here, if you see here, the dy and dx, it says the change of in the y with respect to x. What is the change in the y with respect to the x? Now suppose I have an object which is going from here to here. So I connect these 2 points, and now if I say it is x2 and it is x1. So if I say what is the change in the position, like if I say this is the very first position of that object and it is the second position of that object, and the particle or object travels from here to here. So if I say what is the change in the position of that object in different times. So let I have a time t. So here I will use derivative or differentiation to find out what is the change in the position of that body or object in that respective time. So let's see here, it is x2 and x1. I say it is dx. Let's suppose x is equal to x2 minus x1, and here the particle was at time t is equal to 0 and t is equal to t1. So I say t is equal to t1 minus t0. So what does a dy or dx by dt means? Here the dx upon dt refers to us, it says it is a change in the position with respect to that time. So also the differentiation also tells us about the change in a variable with respect to another variable. Look here, the position is also changing and the time is also changing. So differentiation generally means change in the that variable with respect to another variable. Whether it could be in the form of dy or dx, it is a y dependent function, x dependent function, whether it could be a time dependent function or another variable. So variables could be different. Now we see another use of a derivative or differentiation. The differentiation, let suppose I have a coordinate system which is a two coordinate system, x and y coordinate system, and I have a particle over here and it is a origin and the particle is here. It is a straight line and the equation of this straight line is y is equal to mx plus c. So if I say I derivate this y with respect to x, then will be the meaning of uh, what will be the meaning of that differentiation or that different derivative. So let's see here, if I differentiate y with respect to x, so what will I get here? If I differentiate here y with respect to x, the m is a constant, c is also a constant, so it will remain here m. The m generally means tan theta. It says the slope of that straight line along with the axis. So what a slope means? Slope is the change in the y, change in the y with if I change the position x with respect to y, then the change in the angle, what will be change in the angle is called the slope. If I draw a tangent along this straight line, that will be the slope of this curve. Let's say I have a equation y is equal to x power n. If I have a equation which is this type, I mean to say it is a kind of this y is equal to x power n. Here the y is the polynomial in x. If I have a equation which is a polynomial in x, then how do we differentiate it? Now let's see here. If I say dy over dx, then it will be n x power n minus 1. If I have an equation of this kind, then the differentiation will be this. Now if I take an example of this kind of equation, now let I have y is equal to 48 x power 8, then what it will be the differentiation of this equation. Now according to this, it is a kind of this function. So now the differentiation will be dy dx is equal to 48, it is a constant multiplied with a variable, so it will remain same. So now the power of this x will be multiplied as it is, and the power will be reduced with -1. It is 8, it will be reduced to 7. Here it is the answer. So now the differentiation of this 48 into x power 8 will be, if I multiply here, it will be 4 into x power 7. Here it is the, oh sorry, I got the answer. If I have any equation of this kind, then the differentiation will be n x power n minus 1. Moving to the next kind of equations. Now if I say, if I have a trigonometric function, like what are the trigonometric functions? Sine, cos, tan, etc. So now if I say I have an equation y is equal to sine x. So what a differentiation of sine x will refers us, what does it tells us? Now if I draw the curve of this sine x, it is something like this. The constant amplitude, it is changing with respect to x, which have a maximum value of +1 here and minimum value of -1. It is fluctuate in these two maximum and minimum values. So now if I differentiate this equation, so the differentiation of sine x is cos x. So now dy dx will be equal to cos of x. Now if I draw the curve of this cos x, it will be like something x and y. It will be like this. The curve of this equation will be like this. It will be increasing and with a constant amplitude, which will be fluctuating between -1 and +1. So what does it refers us? Here see, it is 0 degree and here it is pi by 2. I mean to say it is 90 degree, and here again it is 90 degree. And if you see, after differentiating the sine x, I got cos x, which is 90, it is 90 degree more. Now if you see the equation of sine x, graph of sine x, it is like here, and the cos of x is starting from here, which is 90 degree. If I say, if I differentiate this equation again, it will be d square y over dx square. That will be cos, the differentiation of cos x is minus of sin x. This tells us again, if I draw minus sine x, what will be that? It will start from downwards. The equation of minus sine x, I mean to say y x. If I draw the curve of minus sine x, it will be look like this. So now you have got my point. If I keep differentiating the sine x with respect to x, it will be increasing with 90 degree. Once it is differentiated, it is shifted to 90 degree. Again, if I differentiated it with respect to s, it is shifted to 90 degree. Again, if I differentiate it with respect to s, I mean to the third derivative of this equation, it will be minus of cos x. So I will get the equation from here. The minus of cos x will start from here. Now if you got my point, then we can see further. So the point is, if you keep differentiating this sin x with respect to x, after fourth differentiation we will get the same condition, same graph of that sin x. It means for once if I differentiate the sin x, it will be shifted 90 degree curve on the x-axis. So you can see the graph. So this is the meaning of differentiation. So now I'll be discussing some properties of differentiation which are very important. Like if I say I have two functions, if I say y is equal to f1x plus g, sorry, it's not f1, it is fx and it is gx. If I have two functions of x which are added, then what will be the, how will we differentiate this? So now if I differentiate it with respect to x, then dy dx will be f dash x plus g dash x. So differentiation of two addition of functions will be look like this. I will differentiate first function and then differentiate second function, and again we will add them. So here are two more things to know. The dy dx, I mean to say the first derivative of any function y with respect to x can be written in the form of y prime. Here y prime means dy over dx. If I differentiate it again with respect to x, then it will be referred as y double prime. So we can put y double prime in place of dy d square y over dx square, or y prime in place of dy over dx. So here the degree of, I mean to say the maximum power of differentiation tells us the degree of that differentiation or that derivative. It is, look here, it is the first derivative, it is the second derivative. If I further differentiate it with respect to x, I mean to say if I differentiate is with respect to x third time, it is a d cube x over dx cube, it will be y 3 primes. So this is the meaning of primes. So now moving to the further properties of differentiation, which is if I differentiate this and you can say whether I add two functions or subtract two functions, it will be differentiated like this. I will differentiate the first function and differentiate the second function, and we will add or subtract as accordingly the condition is given. So now moving to the next point, which is a multiplication of two functions. If I have fx into gx. If I have two functions of x, fx and gx, I will write it properly. Y is equal to fx into multiplied into g of x. Then how do we differentiate this? So here is a formula for differentiating two functions which are multiplied. So this is like that. It is dy over dx is equal to first function into differentiation of second function with respect to x plus second function and into differentiation of first function with respect to x. So this is the formula for derivative of two functions which are multiplied in this form. So now moving to the next, which is divide of two functions. How do we differentiate two functions which are divide? Now if I say y is equal to, I have a function fx over gx. If I have functions like this, divide of two functions, then how do we differentiate this? So now I will differentiate it like dy over dx is equal to, here I will say, here's the formula for differentiating it. It is second function, I mean to say, if I say this is the first function, it is the second function, then we will differentiate it as like second function into differentiation of first function with respect to x minus of first function into differentiation of second function with respect to x upon gx square of the second function. So if any functions are written as in the form of divide, we will differentiate it as it is. So here are some properties of the differentiation. Now some basic things which we should know before doing differentiation. It is, if I say I have a constant, if I have to differentiate a constant, then what will be that? Constants, like if I say y is equal to, constant could be any numbers, and constants which have a fixed assigned values like pi and epsilon and other constants which have a proper assigned values which can be changed. So if I had to differentiate any constant, then what will be the value? If I differentiate a constant dy with respect to any variable, whether it is time or x, let's say I am differentiating a constant with respect to x, then what will be that? It will be 0. If I differentiate a constant, the differentiation will be 0. So you have seen so many times del x and dx. So what are the difference between del x and dx? So here the del x means if I have 2 points, 2 positions, x1 and x2, the del x refers as the difference between these 2 points, where the dx refers if a particle or body moving in this direction with the whatever velocity is, I don't have to see that. What I mean is, what here the dx means, if the particle is at time t, I mean to say, if it is starts from 0 and reaches here at t is equal to 5 seconds, Then at time is equal to 2 seconds, what will be the position of that particle or body is called instantaneous position, or instantaneous whatever we are finding, whether it could be a velocity, acceleration, energy, whatever we are measuring, it could be that. So it will be called the instantaneous of that particle or that body. If I say it is a position, then here it will be called instantaneous position, and it is written in the form of dx.